Okay, we're in T minus 30 seconds. T minus 30 seconds at the moment, and then we will be getting started. Alright, here we go. Let's start this now. Okay, these problems will hopefully load up. Okay, there we go. Just refresh this one, and let's see. So first problem, we have an integer array, and so we just start with number of test cases. Keep the array in AR. Let's see here. N is the length of the array, we need to take that in first. So our score starts at 0, we need to maximize the score. So every I from k to n, insert it into the bucket, then remove it from the bucket and add to score. So it contains the first elements all the way up to k. Then you place that element and take it. Okay. So let's see if I'm... And for every k we need to find the maximum possible score for the array. So for the first one, it's obviously so k equals 1 is just the sum of the array. And let's look at what's going on with 5. With 5, it's a lowest to high scenario, so you have 160, 150, 129, 97, 54. Yeah, that's just basically the sum of the last element, last 2, last 3, last 4. Yeah, 4 might be more interesting. 18 is just the sum of everything. 16 you ignore 2. 13 you ignore 3. But then you get 8, you ignore 5, okay. I'm suspecting that it's just the highest values, but I'm not entirely sure there. Yeah, if the first n minus 1 element's already in there, and you place the last element, either the largest element's there and you take it out, or you take the largest element is the last element and you take that out. Then with 2, if we extend this to the 2 case where n minus 2 elements are in the bucket already. Okay, so yeah, this is a very simple problem. We just sort here. and n dot reverse. We'll keep our answer in the list. X is 0 for j in AR, x plus equals j, answer dot append x, answer dot reverse again, and then print star answer. This should get the test cases. You can always just take the largest values, the largest n minus k values. That's pretty much the idea here. Alright, we got correct here, so let's just do a quick time recording. 6:10. Okay. And we go to the next problem. So that's one down. Very nice, very nice. So let's see. For I in range read it. And we have a similar input with an array. So there's n tables, each customer sets a table. The group of 3 dishes is delicious if the number of ingredients is divisible by 3. Every consecutive group of 3 tables okay, this is okay, so what I'm getting here is if we have an array, maybe use just here. If we have an array something like 1, 2, 3, 4, 5, then it will take 1, 2, 3, then 2, 3, 4, then 3, 4, 5. So in this next case, the first one is 15, then 3, 10, 25 is 1 off. It has remainder 2. Yeah, 38. Yeah, we need to add 1 here. 47, add 1. 25, 12, and 7. That is also an add 1. Okay, part of the question I'm trying to figure out is what happens if we have like only one case where it's somewhere in the middle. So we have something like 2, 6, that's 8, and then let's make this another 2, so we get 10, and then we can just make this 5, so this is divisible by 3, 2 divisible by 3, so then this is the only problem. 9, 7, 8, so we get exactly one problem. How do we fix this? Or at least what's the best way to fix it? Because if we increment here by 1, you get 7. It affects 2 other ones. Then you'd have to increase the one directly after. So you'd have to make this a 3, I think. So then you increase this by 2, you increase that by 2. So then that would be 3 total problems. Okay, let's just make sure this is the next problem we're going for. Okay, yeah, that is definitely the next problem we are going to attempt. Two, 3, 10, 26. Okay, I think I have an idea here. We can represent all of this information in like an array. So like the previous setup would be 0 for remainder 0, then remainder 0, remainder 1, remainder 0, remainder 0. Our goal is to just make everything into a 0 by minimal increment. What we can do is you can take any group of 3 here and increment everything by 1. Except for the endpoints. You're also allowed to take the endpoints and increment those specifically. So then if you have like a 1 isolated, then you can move it over. So incrementing here is definitely wrong. This is at least length 3, okay. Okay, now the question is this. So with 3 and 4 linked arrays, it's somewhat of a trivial case since since there's only so few like triplets we need to consider. Then there's everything else, n equals 5 and so on. N equals 5, what happens there? Okay, there's something here that I'm not really seeing correctly. I think there is something. Is there a way we can DP the answer here? Actually, wait, I don't think it's entirely a DP setup, because if you have like 0, 0, 1, you'll get 1 as your answer for the number of reductions. Then here you could just take everything here, so then it becomes 3. And then this should still keep being 3, but then if we had like a few more zeros on the other side, there's something else going on there. Actually, what if we just did a greedy approach? Let's just consider the easiest solution here first. So then 2, 3, 10 is fine. You get to 25, you have to increase that by 1. So that's 26, that's fine. Then 12, that's still okay, Does greedy incrementation work here? So 3, 3, 4. Okay, this has to be a 2. Then 3, and then 3. So we just take the 3, we take the 3, we take the 3, we take the 3. Now there's this 4, that's 1. We have to do 6. Then there's a 2. 9, 2, so then this becomes a 3. 3, 3, 3. So then in total 3 fixes were required. Somehow this seems legit. Yeah, I think I'm probably overthinking something here, am I? If k is always 2, then we have to begin this process. I think this might be correct. No, this definitely can't be right. This definitely can't be right. There's no way this is correct. You have 1, 2, 5, 2. Your answer is you just take the 1 there. Yeah, the answer is definitely... Okay, this definitely is not it. I mean, by that logic, we could also use the first increment setup. Okay, I'm kind of thinking of something here. Wait a second. Okay, we go left to right with first increment, so we just increment the earliest one that fixes the problem. Wait, why would we do earliest one fixing the problem actually? Actually, I'm not sure if earliest fix is going to be correct here. Yeah, we get cases where we inadvertently screw something else up. Okay, so we do last fix going left to right, and then last fix going right to left. But then how do we deal with the overlap? Because there will definitely be some sort of overlap in there. I mean, this does fix it, but I don't think it's this simple. There's definitely something that I'm doing wrong here, but I don't know what it is at the moment. Okay, well, if we're getting 015, that probably is fine. Yeah, I'm talking about myself right now. Just trying to figure out the answer here. Okay, so anyways, here, 015, screw it. Wait, how are we getting 015 anyways? Where did I put this here? Okay, print BR after your... So 1, 2, 3, 3, 2, 1. Two, 3, 10, 26, 12, 7. Okay, we're calculating something here very wrong. Yeah, we need to use BR to adjust for change in values. 10, 26, 12, 7, 11, 12, 1, 47. Okay, at least this... It does pass the test cases. We'll give this a try here. It's pretty much greedily choosing the last one and then trying to reverse it. This feels incredibly wrong, but we'll see how this goes. Okay, yeah, so it isn't this simple. Okay, all of these look like they're just doing a linear scan at best. At best, they are linear scanning. I mean, let's just go back to the example. We get a bunch of 3s. And then you do a 4 and a 2. And then a lot more 3s. So this is essentially the 0.00001 case, because by our previous model, if we considered our previous model, that would have just made it, this would have actually been much higher. So in here what we did is this goes to a 6, so that turns this one into a 0. Six, 2, so then yeah, then we get oh wait, this doesn't even work in the first place because okay, 1002, yeah, what is this 2333 going on here? Yeah, that's why it wasn't working in the first place. Yeah, this is actually a 2. If we want to make it there, then we need 4, then we need 2. Okay, and then, yeah, then it is a chain setup. Okay, never mind, I am... Okay. Okay, from this array, I'm thinking there's basically like there's a point somewhere in this array. I don't know where it is, but it's like everything to the left of that has, you just try and subtract everything going to the left. And everything to the right, you do the opposite. can't just subtract every... We can't just test every subarray since that's just unsquared. We need to just find some sort of way to solve left right. So we will have this move and this move. So we have 0, 0. One would be plus 2 there, so then it's 3. I don't know how we find that out though. There's a 0 there, so we just take the previous one, it's a 3. If we take this previous one, we get 2. This puts a 2 there. So then we need... 3, and then this is 1, 1. Okay, wait. Really? Okay, this has to be something. There's 116 people that have solved this. I'm definitely. What the heck am I missing? What am I completely not looking at here? Okay, we know for sure that we have at most 2 increments on each element. Like, if we do 3, we may as well have done 0, so that we know for sure. We don't really know the optimal way. Yeah, this is an optimization sort thing, so we can't entirely tell if it's like this number of increments will work or not. So binary searching is not really there. Okay, previously with our greedy method, how was it being adjusted? How would the array be adjusted? So we do 2, 3, 10. Okay, why am I writing it here? I can just type in the numbers faster. 3, 10, 25, 12, 7, 10. For 6, our end setup becomes +1 here, +1 here, and +1 here. So then what this ends up looking like is a 0, a 0, no wait, 0 and then 1 for, no wait, 2 for 10, 25, 12. And then it did 3 2s. So 3, 10, 25, 10, 25, 12. $47 and then 37 and 44, so that's, yeah, that's another 1, 12, 7, 19, 10, 29, 7, 10, 12 also same case. 10, 12, 1, 2, and then 48, 49, that's a 1. So it just plus 1 here, plus 1 here, and then plus 2, or wait, 12, 46, that's 58, 59, okay, wait, this is also a 2. Okay, somehow we have to take a partial total of... I feel like there's just something we have to do with taking a partial total somehow. Yeah, now we're just getting into full-on what in the heck mode. Like, I feel like there's some left-right DP idea. I don't know how exactly it works, but this somehow feels about right. Something on this feels completely wrong. Now I'm really not sure what's happening. We'll just ignore the fact that that these are going into very fast negative stonk territory. Okay, yeah, we need to look at 2 piles. I'm very stuck on segments. So 2 piles, both initially empty, and n pairs of integers. Okay, choose one of the 2, and then add it to one of the 2 piles. Both piles have to have at least 1 integer. And then what is the minimum possible difference? Okay, if we think about this here, we have at least 2, then whatever we find in the absolute minimum has to be. So it's like if we choose one of the 2 piles. Okay, if we know the exact set. Then what is the optimal setup to divide it evenly? Because I'm pretty sure it's not just like a greedy method where you just split like whichever one has lower, because then you get something like 7 7, 5, and then you could do like 3 4s here, and that would be even. You split this with the greedy method, you're going to an uneven set.
I might go for a walk, man.
Oh, okay. Okay, so let's see here. Wait a second, I'm completely screwing this up, am I? The value is just a maximum element. Okay. Well, this was completely stupid. It's not the sum, it's the maximum element. Then in that case, almost all of this doesn't even matter. Then I think what we want to do is let's see, so we probably want to take the lower of the two values, I guess. How does this work exactly? So with each pair, we have to take one of the two values. Yeah, so set base to negative something like this, just to make sure that we have to include something. Then with each step we get either if the value isn't large enough, it will be irrelevant. If the value is large enough, it okay, I have an initial idea that's probably going to TLE. What about if we sorted the pairs? You could do a replacement A. I mean, at least it works for sure, but then... Okay, I feel like there's something here feels wrong. I think this is n squared, isn't it? It might be n squared. Just by the number of possible pairs. Wait, how are we getting just completely wrong answer? Okay, let's think of it like this. You have to find the minimum maximum. Yeah, that's what we need to do, isn't it? So okay, I think I got it. I know what to do here. and AB equals, we just read ints. The lower of the two has to be at least a 4 for the maximum. And then AR dot bend J and B. This is to signify their value and which pair they're in. AR dot sort. Wait a second. 1, 2. Yeah, if we did 1, 1, 2, 2, we get the maximum. We get a maximum of 2, which breaks things. Second last element is our absolute minimum that we could set. And the thing is if we had that 1, 1, 2, 2 case, it would not be possible. So they can't be in the same pair. And the values themselves have to be at least equal to lowest. Two, 3, 11. Look, I think this should be more accurate, right? We at least don't have time limit errors here. Unless if for some reason there's like some hashing screw up, which is very possible. Okay, so we do not have TLE going on. Now we just have to figure out where's the flaw in this thinking. Yeah, if you take the minimum of everything, then you know what the lowest has to be. Okay, what if we did a second lowest barrier as well? Because it could be that it's okay with the lowest barrier. But then it's somehow breaking down on... I mean, if we have 3 cases correct, we're probably at least close, right? We have to be at least somewhat close to getting the other 2 cases. Come on, please, correct answer. Ah, there we go, finally. We will get more than 1 problem in this contest, thank God. Okay, there we go. We got 2 problems. Now back to figuring out what in the world is going on with segment hell. Either that or we can just throw a desperation attempt at the bit problem here. So we get an array length n bitwise or maximum value across all ways to... Oh, and we want exclusive OR. And these have to be non-empty subsets. So in this case... Wait a second, isn't this just like... Wait a second, stop me if I'm wrong, but isn't this just if you can flag down everything with the highest bit, you just put them in that set, and then you just keep going until... Or you just keep it in another set. Like if there's some in one set and some of them in the other set, then you have to do a reflag. Yeah, in that case it would shut down everything, but then you also notice that it's... So like if you can keep an entire group in the other side for free, then you do so. Otherwise, you just sack the lowest value you can sacrifice. Yeah, I have to make it. Okay, I have to decide very quickly now if I want to attempt bitwise or do I want to try and figure out what is going on with this problem. Okay, so I feel like I have a better idea how to start this. Yeah, I have a better idea how to begin this. So for I in range, read int here, read the array. And then so most to least important bit, all with the current bit that we're looking at in group 1. If and only if it results in a completed group, so then group 2 would have no elements, then possible less group so something like if you have 8, 8, 4, 4, 4, then you split the 8s and you split the let me just make sure I know what the OR symbol is. Yeah, that's the OR symbol, I think. While M is less than or well, B is less than or equal to M double B, and then once we've exceeded, just divide by 2. While B is not equal to 0, and then we just do n past. This is a log task group. Set size will be in SS. It starts off as n. And then running count for j in range n, if hj equals 0, then we have to consider it. Oh yeah, we also have to do a special flag here. Okay, so we can actually do something like if ARJ or our bit B equals ARJ, it's included. Then if HJ is 0, if none of them have it, then you can't really do anything with it. If it's not there, like it's a new element, then our count goes up by 1. Otherwise, exclusive becomes false, and we just so then from here, if C is not equal to SS, then flip that into the group 1. This is our special case. If it is not exclusive, so there's something there so that even if we do that split, then we just continue with our next bit. And if it is exclusive, but then it just applies to all of the elements, then it doesn't really matter. We have to, then it's impossible whatever we do. There. So then after this, just divide by 2. Now we go G0, G1 equals range n if H 0 equals G0 or a R's (14, 3, and 7). I mean, 3 problems would give us a bit of a boost, but then, I mean, if we can get segment 3, then we actually have 4 problems, which is a really good run. But then we have to get this first. It's still running, come on. Okay, wrong answer. Okay, so 4 of these are right and the rest are all wrong. Thing is I feel more confident in this question. Okay, wait a second. There's a 0 there. And now that I think of it, I'm not sure if... Oh, okay, well, there's your problem. There is a problem. And also, I don't know where the heck is 0 going. Okay, so we have to take 2 more into consideration. If AR.count0 is not equal to 0, if everything's the same, I mean, we're also screwed. So let's for in AR, answer equals answer or II. So that gives 0. And then if we do 1, 4, 0, 1, 2, 4, this should 7, yep. Okay, that eliminates a lot of possible screw-ups. Okay, now we just hope and pray this somehow works. Because I think my main part of the solution seems about correct. I don't know if there's any other edge cases that could screw it up though. Okay. Okay, so yeah, okay, never mind. If all of these are wrong, then probably, yeah, there's something in my main solution I might actually be overlooking. I mean, same numbers and 0 case are definitely correct. And what else could it? Because you want the most important bit. Sometimes it. You always want the highest bit possible to work, and then you look at each bit afterwards. So like if every bit has the highest, if every value has the highest bit in it, yeah, then it's definitely impossible. Take the highest. So our bit starts at 1. Wait a second. What if it isn't a complete setup, but then it's also still exclusive? So stuff like 8844 and then 1, that would qualify as like exclusive but not complete. Would there be a difference between placing it in the same group? Then it puts 8855. Yeah, that's definitely a problem. That is very much a problem here. Think 1588551. You can get 13 out of this. And then if you put the 2 somewhere, so if they are split across, So all of the 8s you consider in it. And then if 4 overlaps, then you have to place 4 with it. So if it completes everything and it is not exclusive, if it completes but it is exclusive and it isn't, it says N, if we get a second group, we can always just, if we have a third group in this scenario, you can always just combine it with one of the other 2 groups and it will be fine. If it's not exclusive, not if it is completed, so you have all the elements are inside. But then, more importantly, it's not exclusive to either of the 2 current groups. Okay, -1 signifies no group. Just so if not exclusive, not if it is exclusive and then we have and it's not completed, wait a second here. Okay, if it's completed, so the entire thing's completed, so if you put that all in the group, there's nothing else in the other group. And it's exclusive. So it only contains values. So this is the exclusive and complete stage. Yeah, then you just take out and you just place in. Okay, let's make these 53s. Or no, wait, let's make these like. Yeah, let's make it this number. So in that way we. In this case we have to set it to HJ. This way we don't. Okay, so if exclusive and complete, if not exclusive, not complete, so if it does include something with another value, yeah, then LF exclusive equals the very large number we have. And C does not equal SS. Do we still want to subtract C? In the case we figured out prior, it would be the exclusive would be 1. Yeah, it's not exclusive, but Okay, yeah, now we get 1537. We're doing -1 somewhere. Okay, yeah, that will not be the case. Okay, and then we need to test 88551, I think. Still 12. Then we just have to find a... Yeah, this might be wrong. This is probably wrong. But I have 1 minute. I have 1 minute. 1 minute and just... We are going for... This is a desperation, bro. This is... Simply put, a desperation attempt. Like I might have a runtime error here, but and I'm probably getting a wrong answer. Yeah. Yeah, I think what I needed to do was like, you take the powers of 2, put them in their own groups, and you have to like group them up correctly. Yeah, this was a this was a bit of a contest. Mainly this problem, yet another bitwise problem. This one's probably I solved this if I don't burn all that time on segment 3 doing whatever it was I was trying to do. There's also maximized ones, which I didn't look at, and it might have been very possible. Yeah, looking at it, maximized ones also had decent chances. Anyways, I think I'll be cutting off the recording here first, and then I'll make another recording later on with the unrated problems of Starters 99, and upload that later on.